Hello and welcome to another segment on matrices. Today we shall be discussing about multiplication of matrices. Later we shall deal with properties of matrix multiplication, and finally we shall conclude this segment on matrices by discussing some numerical problems that would be based on matrix multiplication. So starting with multiplication of matrices, two given matrices, let's say A and B, can be multiplied if and only if the number of columns in matrix A is equal to number of rows in matrix B. That is, if A is of order m by n and B of n by p, then the multiplication of two matrices AB is of order m by p and is given as AB equal to C, whose elements are obtained by multiplying A and B, and the order of C is m by p. The elements of the matrix C, which is obtained by multiplying two matrices A and B, is equal to sum of products of elements of ith row of A and corresponding elements of kth of column. Now we can make it clear by taking an example of two matrices. Let's say A is given as a second order matrix whose elements are 2 minus 1, 2 minus 3, and B is also a second order matrix whose elements are 0, 5, 1, 2. The first and foremost thing to be seen is that the two matrices can be multiplied since the number of columns in A is equal to 2, which must be equal to the number of rows in B, which is equal to 2. Therefore, these two matrices can be multiplied to obtain a matrix C, which is equal to the product of A and B. This gives us the value of the matrix C, which is equal to the product of A and B, and whose value can be found out as 2 into 0 plus minus into 1. The second element of the first row is given as 2 into 5 plus minus 1 into 2. The second row first element can be written as 2 into 0 plus minus 3 into 1, and the second row second element can be written as 2 into 5 plus minus 3 into 2. This gives us the first element of C as minus 1. The second element of the first row is given as 10 minus 2. The third element is given as minus 3, and the fourth element is 10 minus 6. Thus C is obtained as a matrix whose value is minus 1, 8, minus 3 and 4. This gives us the value of the product of two matrices whose values were defined earlier. Now we are going to discuss some properties of matrix multiplication. So starting with the first property of a matrix multiplication, which is that multiplication is distributive over addition. For this we are going to suppose three suitable matrices as A, B and C. Then according to this property, the multiplication of A by a matrix that is obtained by the sum or addition of B and C matrices is equal to the matrix whose sum is obtained by addition of AB and AC. The next is that multiplication of matrices is associative. That is, if A, B and C are suitable matrices, then the product obtained by multiplying AB with C and the product obtained by multiplying A with BC are equal. The next property states that if A and B are two suitable matrices and K is a scalar, when the product of AB is multiplied by a scalar K, this gives a value which is equal to A's multiplication by a scalar K, which is then multiplied by a matrix B. This is further equal to the scalar multiplication of B multiplied to A. Another is the existence of multiplicative identity. For this we consider a matrix A which is of order m by n, then the product obtained by multiplying the identity matrix of order m with the matrix A would be equal to the original matrix A, and this would be equal to A into unit matrix of order n. Here Im and In are unity matrices of order m by m and n by m respectively. Next property of matrix multiplication states that product of any matrix and a suitable null matrix is always a null matrix. For example, if A is a matrix of order m by n and has its element as aij, then the multiplication of null matrix of order p by m with a matrix of order m by n is equal to a null matrix of order p by n, and the product of A of order m by n and O of order of n by q gives us a null matrix of order m by q. Next, moving powers of a square matrix. Here we consider a square matrix of 2 by 2 order, and thus A to power 1 is equal to A. A square can be obtained by multiplying A twice, and similarly A cube can be obtained by multiplying A thrice. Finally, we are going to discuss a numerical problem based on multiplication of two matrices. In the given problem, we have been given a square matrix of order 2, that is A, whose value is 1 0 minus 1 7, and an identity matrix of order 2 by 2, and we are supposed to find out the value of K, which is a constant, so that A square is equal to 8A plus Ki. So we are going to start by equating the value of A square, which is obtained by multiplying A twice. That means we are going to obtain the product of matrix 1 0 minus 1 7 and 1 0 minus 1 7 again. Now cross multiplying these two matrices, we have 1 into 1 plus 0 into minus 1, then 1 into 0 plus 0 into 7. The second element of the first column is minus 1 into 1 plus 7 into minus 1, and the last element of A square would be given as minus 1 into 0 plus 7 into 7. This gives us the value of A square as 1 0 minus 8 and 49. Thus we have obtained the value of A square as 1 0 minus 8 and 49. Now we move to the right hand side term of the given equation, that is 8A plus Ki. Now here we are going to perform the scalar multiplication of A by 8 and the scalar multiplication of K with I. This gives us the value of 8a plus ki equal to 8 plus k, 0, minus 8 and 56 plus k. Now since it has been described in the question that a square is equal to 8a plus ki, that means we are going to put the value of a square equal to 8a plus ki, and we'll obtain the matrix equation of this form. Now equating the first element of 8a plus ki with the corresponding element of a square, we have 8 plus k is equal to 1. This gives us the value of k equal to minus 7. Thus, in order to satisfy the given equation, the value of k must be equal to minus 7. With this, we conclude this segment of matrices in which we have discussed about matrix multiplication.